So let's suppose that you have trained your deterioration model on a synthetic data set. And what you would like to do next is to really verify the performance of the deterioration framework, provided that you have the true state, the true deterioration state, and the true parameters available in the synthetic data set. So to do such verification analysis, what we can do is use the toolbox verify synthetic data, which can be accessed from the main interface of OpenIPDM. We go to analysis and then verify synthetic data. So click on this and it would open the interface for verifying synthetic data. And as you'd see here, there are many inputs that we can provide to this interface. We'll start with the load synthetic data section, and we have the load true and observed data. So this file is really available in the data set, data set from the generate synthetic data toolbox. So we go to help, synthetic data, and we go to full and short. So full, it means that we have the full true trajectory for the deterioration, and short refers to also we have a short window of observations, which is like really our observations. So we load this file full and short. Then we move on to the next file. We have load true inspectors. So this is really to load the true inspectors parameters. We go to the synthetic data folder and we go to true inspector. So these are the true parameters for the inspectors. And we have to load the estimated inspectors parameters. So we go again to the synthetic data folder and we go to this time to the parameters, which are the ones that I obtained from my deterioration model, updated inspector data. So I've done this. Now I move on to load the final file here. Now this file is optional in case if I'm using the regression model, I load the file. In case not, I just move on and fill other inputs. So in this context, we are actually have trained deterioration models. So I would go ahead and load the parameter file. So demo data, synthetic data, parameters, KR param. Now loading the parameters and the dataset almost done. We have finally the table for the general parameters. So we have the first row is for the true model parameters. So I'm gonna input these true parameters for the synthetic data. Now and moving on to the estimated parameters. So you go ahead and also input these parameters. These parameters exist in the parameter file that we have. So if we load this file, it's actually the file param. I can load it and I can input these values. So go ahead and for me, in general, the expected value for the acceleration, expected value for the speed are 0. Here we have the min speed is the last value in the table here, which is 0.15, and for the sigma acceleration 0.05, for the speed 0.05, and we have the condition, it's 1, and for the sigma w 0.038. So these are the general model parameters, again provided after the model training step is done. So from there we go to provide what's the verification setup that we want to do. So we have for example, the forecast time. So how long we forecast after the inspection data. So here it's 10 years. And we have also the observations window. So let's say like my inspection data are spent on what the length of the time window, that's my inspection data stand over. So since synthetic data, I have like such information. And finally, we have the number of structural elements or the number of time series that I want to involve in my synthetic data verification. Because imagine the synthetic data, or in general in any data set, there would be like around more than 10,000 or 18,000 structural elements or time series. So I don't want to wait such a long time. I can just rely on a subset of these structural elements or time series in order to do my verification analysis. So this is like for the input part. Finally, the last part here is that there is the output. So we have, so in case if you want to have a subset of the time series out of the 500 that I'm performing the analysis on, I want to have randomly selected 20 time series to be plotted and stored. The storing in these time series will be in the folder of the toolbox. So if we go to the folder tools in the OpenIPDM folder tree, and we go to predict real and synthetic data, we have two folders here, abnormal graphs and graphs. So these are where my graphs or figures are going to be stored in general. So these are for the time series specifically, like individual structural elements. So these are in general the for the storage or one of the output. Now, in addition, what we have here a list of figures or outputs. All of these figures would be generated at the end of the verification analysis. So after finishing the analysis over 500 structural elements, I would get all these figures except for the this checkbox, which is the condition speed acceleration, which would plot the time series as the verifications are being performed. So that's like purpose of it. Each one of these is exists with an example in the manual document. However, if you would like to see, for example, the forecast error graph, we can click on, we can try to click on run, and it will take some time to process the 500 structural elements. However, once it's done, it will open the figures with the forecast error, and these are figures which show that for a combination of 500 structural elements during forecast time, what is the absolute error and what's the error in general. So we can wait to see these figures just to make sure that it's still running in the background. So it might take a few minutes to do these processes. We will wait for it. But in general, these are the each one of these outputs is detailed with the figure example in the manual document. And as I mentioned earlier, all of the inputs are important except for the regression model parameters. So we have the figures ready here. So we have the average error, and we have the average absolute error figures for the we have the acceleration, the speed, and the condition, and similarly for this graph. So that's all for the verification analysis. As I mentioned earlier, you can always refer to the PDF manual document.